there. This is Dr. C. Sonia, Assistant Professor in Chemistry, SNS College of Technology. Now, in this video, we are going to see about energy sources. So, we have various different energy sources. Here, particularly, we are going to concentrate upon the renewable energy resources. So, what is energy? Energy is nothing but its capacity to do work. So, we rely upon different types of energy in different circumstances. That is, in the olden days, we were dependent upon wood, then we went for coal, oil, and now we have different alternate sources of energy. So, how energy is used per capita? So, that is very important to know about the energy distribution in the world scenario because energy distribution is not even throughout the world. So you can see that the developed countries like USA, Canada, where only 5% of the population is there, but their energy consumption is almost 25% of the world's energy resources. So from the graph, you can see that the GNP on the x-axis and the energy consumption on the y-axis, and you can see along the line various countries that how much they use the energy, and you can see in that the USA, Canada, they use more amount of energy, but the poor countries like Bhutan, Nepal, they use very less amount of energy. So Dr. H.J. Baba, he's called the father of the nuclear physics in India. We're going to see about the nuclear fission reactions and how the energy is obtained from this. By 2012, 20 plants contribute to 3% of the total energy production in India. There are two types of reaction to produce nuclear energy. One is the nuclear fission and another is the nuclear fusion. Nuclear fission, it's nothing but it's a process of splitting the heavier nucleus into two or more lighter nuclei on bombardment by slow moving neutrons with the liberation of large amount of energy. So example for the fission reaction, a common example is uranium 235. So when the uranium 235 it is bombarded by the neutron, it gives barium 56 139 along with krypton 3694 and 3 neutrons plus energy. So in this we can see the mechanism, that is uranium 92 235 plus 1 neutron. It gives uranium 92 plus 92 36, which is unstable, and this unstable uranium it releases barium 56 140 plus krypton 36 93 plus 3 neutron, and next is the xenon 54 144 plus strontium 3890 plus 2 neutrons, and next is the cesium 55 144 plus rubidium 3790 plus 2 neutrons. So it is illustrated in this figure, that is the incoming neutron. It goes and bombards with the uranium 235 to give uranium 236, which again splits up into two different nuclei, releasing 3 neutrons. So that's explained pictorially. There are certain characteristics of the nuclear fission reaction. The uranium 235 heavy nucleus splits into 2 or more smaller nuclei. 2 or more neutrons are produced. Then the large amount of energy is released from the small mass. Fission fragments are radioactive. They release beta and gamma radiation. Atomic weight of fragments ranges from 70 to 160. All fission reactions are self-propagating because of secondary neutrons. So the secondary neutrons that is through the fission reaction, it again goes and hits another nuclei and it causes a fission reaction. Okay, by observing the desired number of neutrons, we can control the fission reaction. So this reaction will be just going proceeding, but by reducing or observing the neutrons that is coming out of the fission reaction, you can have the control over the fission. Then secondary neutrons does not collide with the nuclei. Some escape into the air. So all the secondary neutrons, they does not collide, and multiple factors, that is the number of neutrons resulting from a single fission, if it is less than 1, okay, then the chain reaction will stop. So as we saw that you can control the chain reaction by reducing or by observing the number of neutrons. So there are certain advantages of the nuclear fission reaction. Small amount of nuclear fuel, it will give you huge energy. Long-term usage of fuel in nuclear reactor. So contrary to it, in thermal power plants, fossil fuel is to be supplied continuously. And there are certain disadvantages. There is severe pollution than the burning fuel, fossil fuels, and the biggest problem is the waste disposal. As we know, that is the nuclear fission reactions. There is emission of different types of radiations, alpha, beta, and gamma radiations. And these radiations are very harmful, and it is very complicated work to dispose all these nuclear waste. In most of the cases, they are buried deep into the earth, but still the radiations will be coming out of the fuels. Thank you.